once I know how to transform a quadratic, I know how to transform everything. Once I know how to transform a cubic, I know how to transfer anything, because transformations for all functions works the exact same way. So it says the graph of a function y is equal to a times f of x minus h plus k is a vertical. It starts going off about the transformation. So I'm going to start here, okay? So if f of x is our parent function, f of x, parent function means no shifts, everybody. A parent function is the most basic non-shifted function. So now it's saying we can take that and we can do these shifts. So if we have a times f of x minus h plus k, we have all these transformations happening. So they do f because they're saying it can be any function. So they're not getting specific because it works the same for all functions. So they're saying given a function, whatever function it is. Okay, so here's how the first, see the a in front here. The a being times in front here. That is going to be what does a vertical stretch or compression of the function. Now vertical is up and down, everyone. So let's just say I have the parent function x squared and I was to graph x squared, and it looks something like this, let's say. So if we now take and have a 2 in front, it's considered a vertical stretch, and here's why. The acceleration is going to go up quicker. You guys see what I'm saying? Here's my normal quadratic, and now it's going up quicker. You see how that stretches it up? Going up quicker. So it's vertically, like a rubber band, stretching it out up vertically. Now, if it's a 1/2, for example, if it's less than 1, below 1, it's going to be a compression. So what I mean by that is the acceleration is slower. So look, that would go out like this, which is compressing it, vertically compressing, squishing it. You guys see how that's working? Stretching or compressing. So the rule is, if your a value is greater than 1, it's considered a stretch. If your a value is below 1, it's considered a compression. Now, we have to be careful, though, because negatives are not included in this rule. Negatives are actually their own transformation. So when I say a is greater than 1, it's the absolute value of a. So even a -2 would still be considered a stretch. The negative is its own transformation, which we'll talk about in a second. So it's the absolute value of a. Okay, so now that's how we stretch or compress our function. That's our acceleration. Now the x minus h part, the part that's grouped in with x, the part that is grouped in with x, is your shift left and right, and as we just saw, we go opposite of the sign. We will talk about y in more detail in the next slide, but she hit it dead on. She has it exactly right. The algebra will work out. So it is going to be opposite, shift left and right. Then this plus k is added on the outside of the function. It's added just to the outside of the function, and that's our vertical shift up and down, and the sign will stay the same. So now the negatives. So a negative in front of the function, a negative in with our a negative in front of f of x, will take and reflect the function over the x-axis. So for example, look right here at this pink point. If I take that and I plug in -1 times the y values, -1 times the y values, wouldn't that take your y values down here? So a negative in front of f of x is a reflection over the x-axis. Because, guys, look, right here, negative f of x means negative y. You see that's -1 times y, everyone. -1 times our y values. Okay. Then right here, if we plug in a negative x inside with x, it's going to be a reflection over the y-axis. Now think about why. If I'm at this pink point, we're at some positive x-axis. If we plug in that negative x, now we're over here. So that would be a reflection over the y-axis. So we have 5 transformations, and they're always going to work for shifting of functions. Those are going to be the 5 transformations we're going to see. So have those down, and then we'll just start practicing with them. So watching very carefully, so watching this. If I have a line, let's just do a line to make it really easy. Here's a line. I have a parent function y equals x. See, there's no shifts. There's the parent function. It's basic. There's no shifts involved. So I have the point 0, 0. Now if I take and just shift this right 3 units, so right 1, 2, 3, I'm now at this point. Do you agree? Okay, so I have this line that's shifted over here. Now that is the point over 3 up 0, isn't it? So now we're asking, well, should that be y is equal to x minus 3 or y is equal to x plus 3? Well, like she was saying. Uh-oh, I wanted that to be out of my way. Okay. So now let's plug in. What point do we have? 3, 0. Isn't that where we need to end up? X, Y, everyone. So let's plug that in both. So our X value is 3. Not X, sorry. Our Y value is 0. So we have 0 is equal to, and then our X value needs to be 3 minus 3. Let's plug it in here. Our Y value is 0, and our X value is 3 plus 3. So let's see which one's a true statement. 0 equals 0. 0 equals 6. So if it was plus 3, that would not be true. If we would not land on that point. Do you guys see what I'm saying? So it needs to be opposite so that when we plug it in, it becomes 0. That's what she was saying. Do you guys see why? Okay, because when we plug in positive 3, it needs to come out 0, so it needs to be opposite. Awesome. Now we understand why it's opposite. Because I might ask you that on a test. Okay, so right here it says, what is the equation of the graph y equals x cubed? Now guys, that's a parent function because there's no shifts. So look, x cubed is a parent function. Y is equal to x squared is a parent function. Y is equal to x is a parent function. Y is equal to the absolute value of x is a parent function. Y is equal to x to the 4th is a parent function. I could go on all day. Do you guys see how I can write parent functions for all functions? Y is equal to 1 over x would be the parent function because there's no shifts on all of these. So right here we're asked to take x cubed and transform it in the following ways. So it says right here, do a vertical compression by a factor of a half, followed by a reflection across the x-axis. Then we need a horizontal translation of 3 units to the right, and then a vertical translation of 2 units up. So let's see right here. It says step 1, we take and times it by a half. Isn't that what we do? A is the stretch or compression. Then it says then make it a reflection over the x-axis. So that would be a negative in front with our h, because that's -1 times the function. Then it says then do a shift of right 3 units. So then it would be x minus 3 in parentheses. Shift left and right are grouped in with x. It's cubed, and then it said 2 units up. So then we would add 2. Do you guys see how to do it? We just add it all in. Okay, so let's answer this one, then I'm going to let you go for on the homework. Okay, we're taking x cubed, and we're doing these things. A vertical stretch by a factor of 2. I always start with shifts left and right, so let's actually do that. So we're going to have y is equal to, is there a shift left and right? 3 units left, so we're going to have parentheses x plus, just left and right go opposite, x plus 3, and then this is a cubed function, right? And then is there a shift up and down? Up 4, so we'll have plus 4. And then it says a vertical stretch by a factor of 2. So we need to put a 2 in front. Really easy, right? Okay, one more. Let's say y is equal to, I always do a shift left and right first, so it's shift 3 units right, so that'd be x minus 3. This is a cubed function, so degree 3. And then 4 units down, minus 4, so check, check. It says a reflection across the x-axis, so that's a -1 in front, right? -1 in front. And then it says a stretch by a factor of 5/3. So like this. The stretch and compressions are multiplied in front. That's our A value. Now why is that considered a stretch? Because 5 divided by 3 is still larger than 1. Even though it's a fraction, it's still larger than 1. So it's still a stretch. Okay, awesome. Now what if I would have said, what if I would have added in also a reflection across the y-axis and y? Where would I also put a negative then? In front of x. Okay, awesome. Do 1 through 4, go. Okay, once again, if you can transform a cubic function, you can transform any function because they all work the same. So looking up here, if I gave you the function f of x is equal to the absolute value of x, and asked you to do it right 2, up 3, compression of a third, reflection over x, you can't freak out because it works the same way. So you'd say, okay, so f of x is equal to, I start with my shifts left and right, so I have an absolute value function. And then it's right 2, so that'd be x minus 2. And then it's up 3, so plus 3. And then it's a compression of a third, so that's times in front of the function. And then a reflection over the x-axis, that would be in front multiplied with my a, right? Easy. Okay, awesome. So what I want you to do is now show me, you could do this one and this one. Guys, base e is just like having a base like this. F of x is equal to, for example, 3 raised to the x power. E is just a number. E is approximately 2.7, so just so you know. Once again, though, I should be able to give you any function, a function you've never seen before, and you should be able to write this in. Misconceptions. So watching, guys. So we know that no matter what, we always group the shift left and right with the x. True? And then the shifts up and down are added to the entire function. You weren't just grouping it with the x stuff, were you? Okay, so let's think about this. Let's look at the e to the x one. So we'd have f of x is equal to, now shifts left and right are grouped with x. A lot of you are grouping it with e, but it's e raised to the x. So if it needs to be grouped with x, wouldn't it be up in the exponent with x? So we would have an e, it's grouped with x. X is up here. So that would be an x minus 2, like that. Now we're going to add 3, but you don't add 3 to the x. That would be like adding 3 in here. We add 3 out here, right, everyone? Yeah. And then we would take and we times the entire function, not the x, but the entire function in front by negative a third. Are we good? Does everybody see how you were kind of just off in your thinking a smidge? Okay, awesome. So if I was to now give you on the test this one, 1 over x squared, you would just do it the same way, right? We times by negative third in front. We'd have an x minus 2 in here and a plus 3 out here. Do you guys see what I'm saying? Okay, cool. Okay, awesome. Now here's one thing to note. So recall, when solving a quadratic, we will have to account for the positive possibility and the negative possibility. So for example, if I said what squared equals 16, we know that positive 4 squared equals 16, and also negative 4 squared equals 16. Or more commonly done, we do the square root, then root cancels out with power, and we know we can't forget when we take square roots, plus and minus, right everyone? So plus and minus 4. So now that is, look, x squared equals 16. This is a parent function, isn't it, of x squared? So now think about it. If we have a parent function that has a solution of plus and minus 4, now we take and shift the parent function and shift the solutions, because if you think about it, if we graph it, we have our solutions, and now we're shifting it right 3. Won't that just take your solutions and also shift them right 3 units? Yes, so when we solve this, you could do it 2 different ways. You could say, okay, so square root, root cancels out with power, doesn't it? So we have x minus 3 is equal to plus or minus 4. So we have x minus 3 equals 4, and we have x minus 3 equals negative 4. So this is saying take the function and shift it right 3. So shift it right 3, and where do we get? X equals 7. Do you guys see? Or just think of it as algebra. Add 3, we get 7. So right here, add 3, we get negative 1. Now think about why that makes sense. If we had a solution at negative 4 and then shifted it right 3 units, it's now going to be at negative 1. Now, so you're saying, so even roots will have 2 solutions, but what about odd roots? So let's look at odd roots. X cubed equals 8. Isn't that 2 cubed equals 8? So that if that's true, then the cube root of 8 must equal 2. And only 2, because negative 2 cubed is okay. That does equal negative 8, but not 8. So odd roots, we can take a negative, and we'll just get a negative answer. Do you guys all see why? Even roots, no. Odd roots, we have 1 answer. Even roots, we have plus or minus. Odd roots, 1. Okay, so if we know for a fact that x cubed equals 8 is the parent function, this is the parent function, how many real roots does this one have? It only has 1. Now how do we know that? Let's think about it. Isn't this what x cubed looks like? Well, it's only crossing 1 time. Crossing the x-axis 1 time. We know it has 3 solutions total, but there's only 1 real root because it only crosses once. Even if I take and transform this, isn't it still only crossing once? Yes, so all shifted cubics will only have 1 real root, and that's because when we take the cube root, there's just 1 answer. Okay, so let's solve this. Find the solution here. So we cube root both sides. Cube root. So then we have root cancels out with power. X plus 3 equals 2, and then we're shifting it left 3 units, or just do algebra, subtract 3. So x equals negative 1. That's the only real root. So there must be 2 imaginary roots, right? Okay, awesome. I'm not asking you to find them. We could, though, because we could put it back in standard form. We could get a set equal to 0, we could do synthetic division, and then we could solve the quadratic. But I'm not asking you to do that. Okay, find the one real root. So cube root, so then root cancels out with power. X plus 3 equals -2. Subtract 3, so x equals -5. Are we all good with that? Okay, odd cubics that are shifted from the parent function will only have one real solution. Okay, just making sure we're good with this. What's the cube root of 1? 1. What's the cube root of 27? What's the cube root of -1? What is it? -1. It's not I. It's not I. Okay, the cube root of -27. -3. That's all good. We can have negatives under odd roots. Okay, awesome. Okay, so now if I said to you in general, given y is equal to -a times x minus h cubed plus k, if I said to you, how many real roots will this have? You would say 1. It's a shift from a cubic. Cubics, x cubed only have one real solution. So on a test, this would be a good, deeper thinking problem. Now, if you said 1, then I'd say, and tell me what the root is. How would we do it? Find the 0. Now, guys, when we're finding zeros for quadratics or any function, we set it equal to 0, right? That's by definition. What we're finding is when y equals 0. So plug in 0. So 0 is equal to -a x minus h cubed plus k. So solve for x. So what would I do first? Subtract k. So -k is equal to -a times x minus h cubed. Then what? Divide by -a. So now we have k over a is equal to x minus h cubed. Then what? Cube root it. Cube root. So we have the cube root of k over a, and then is equal to x minus h, and then add h. So we would have the cube root of x, oh, that's a k, sorry, of k over a, and then we have our plus h out here equals x. True? So there it is. There's our one real root. Okay, awesome. So let's use that now. Okay, so it says, what are all the real zeros of this function? You'd say it's a shifted cubic, so there's only one of them. It's when we're finding zeros, we have to set it equal to 0. That's what the definition of a 0 is. So 0 is equal to 3 times x minus 1 cubed plus 6. Now solve for x. -6. -6 is equal to 3 times x minus 1 cubed. Then what? Divide by 3. So we get -2 is equal to x minus 1 cubed. Then what? Cube root both sides. Cube root. Is this a problem? Can we have a negative under a cube root? Yes, and then what will happen with that? It'll just be a negative answer, won't it? So we are going to pull out the negative because it is a negative outside. So negative cube root of 2 is equal to x minus 1. The root canceled out with power, then what? Add 1. So we have negative cube root of 2 plus 1 equals x. Does this cube root simplify? No, so we're done. I want an exact answer. If the cube root did simplify, you'd keep going. Does that make sense? Okay, now, if it was a fraction, you would split up the fraction from the top and bottom and see if it simplifies. Okay, sweet. Okay, so I just want to look at these two, and I'm going to let you go for it, but you need to watch these two. Okay, so it says find the zero. So you'd say, oh, this only has one real zero. Find the real zero, it says. This only has one real zero. I have to set it equal to 0. 0 is equal to -3 times x plus 4/5 cubed plus 8/9. Now subtract 8/9. Everyone watching, -8/9 is equal to -3 x plus 4/5 to the third power. Then you would divide by -3. Guys, watch. If you divide by -3, you have to know how to divide fractions. Let's think more advancedly in our algebra from here on out. How can I undo this if I'm going to have to be dealing with fractions on this side? Can't I times by -1/3, and that's the same thing as dividing by -3. That's smarter. Times by -1/3 is the same thing as dividing by -3. So now I can just multiply fractions straight across. We get a +8 on top and a +27 on bottom. That's equal to, those cancel out, x plus 4/5 raised to the third power. Then we'll cube root both sides. Cube root. We have a fraction. We need to split it up. So we have the cube root of 8 over the cube root of 27 is equal to x plus 4/5. Now see if the cube root simplifies. 2 over 3, not plus and minus, right? It's either positive or negative. This one was positive because they were both positive. And then that's equal to x plus 4/5. So now we'll subtract 4/5. So we have 2/3 minus 4/5 equals x. You could type it into your calculator, hit math, enter, enter, or just get a common denominator. So times by 5 over 5, times by 3 over 3. So then we have 10/15 minus 12/15 is equal to x. So then that's -2 over 15 equals x. There's our one real root. You can just type it in your calculator. 2/3 minus 4/5 and then hit math, enter, enter. And then we'll change it back to a fraction. Okay, so I think we get the picture here. Do you? Okay, sweet. Do 5 through 10 go. When you're done with number 8, check your answer. This is what it should be. So what do we do if we have a negative inside a cube root?
Oh, moves out.
Yeah, moves out.
And then the -1.
Yeah. We got to explore. We've been looking at transformation of functions, which is great. Now, what do we know? If it is a transformation, it's going to have that one form, this form. So let's focus on a cube, for example. Y equals x cubed. A transformation of that will have this form, as we've seen. And it will have only one real root. So right here, this has one real root, and that's a transformation from the parent function. Now here's the thing though, there are cubic functions such as this, y equals x cubed minus 2x squared minus 5x plus 6. I have graphed it over here on the right. How many zeros does it have? Real zeros. How many real zeros does it have? 3. So it must not be a transformation from the parent function, because if it was, it would only have one real root, for sure. Does everybody understand that? So there are cubics that are transformations, and there are cubics that are not a transformation from the parent function. So can anyone tell me the main difference you notice in this equation versus this one that might help us be able to see if it is a transformation versus if it's not? Yeah.
You have x cubed, x squared, and x.
Good. So you're saying we have multiple x's written here. Yes, that is true. And then up here we only have one, right? It's a transformation of the just x cubed. Does everybody see? So that is always going to happen. So if you have multiple x's, it's not written as a transformation. You can't even tell me what the transformation is there because it's not written as a transformation. So it's not a transformation. Okay, so same way it says right here. Similarly, some quartic functions are simple transformations and some are not. So let me show you some quartic functions. So looking at degree 4, here is a quartic function that is the parent function. So quartic is degree 4, so x to the 4th. There's our parent function, x to the 4th. Right here I've graphed it. So if I take and shift this, this technically has has technically 2 real roots, 2 real zeros. So right here, if I take and shift this, let's say I shift it down. I can't draw that very perfectly. Do you see how it would have 2 real zeros, everyone? So if I shift it around, it's going to have 2 real zeros or none. Because if I shifted it up, now it's up here, it has 2 or no real zeros. So a shift from a quartic, well, that will always be true. But now look right here. Here's a quartic that crosses 1, 2, 3, 4 times. This is not a shift from this function. They're totally different. Does everybody see? Okay, so not all functions are a transformation from the parent function. So let's answer this question. It says, determine whether each function can be obtained from a parent function. If so, what's the parent function? And then what is the transformation? So this is not on the homework. We're going to go through this quickly. Could this one be a transformation from a parent function? Yes. There's 1x. Why not, right, everyone? What would the parent function have been? X cubed. And then if that's true, what was the shift? Okay, so we just say stretch of 4, right? Stretch of 4, and the negative is its own transformation. So reflect over x. Okay, awesome. Moving on. Let's look at this one. Is this a transformation from the parent function? No, because there's 2 x's. You could not tell me the shift there, could you? So not a transformation of the parent function. Right here, this is a transformation of the parent function x squared, and we would say it's a shift of right 3, up 5, stretch of 2. So this one was a yes. All right, now looking at this one, is this written as a transformation from the parent function? No, we couldn't determine the shifts. Now, quadratics actually have a fluke. There is a fluke with quadratics because technically we could complete the square and write it in vertex form. But we're just going off of right here, right now. Can we write it? Does that make sense? Quadratics can be rewritten always as a transformation, but we're going off of right here, right now. Is that a transformation from the parent function? No. How about this bad boy?
Yes.
Yes. What would my parent function be? 1 over x, and then the shift is? Left 2. Is this one a yes or no?
Yes.
It's a yes, and it's a shift, it's a parent function of? 2 to the x. And then this is a shift of? Up 3. Okay, good. And this one, transformation from a parent function. Nope, there's 2 x's. How about this bad boy? No, there's 2 x's. Okay, you guys get the picture. You get the picture. Awesome. So what I want you to do is go to problems 20 to 25 and answer these same type of things. 7. So there's 2 ways to do this one. There's a way that I call the easy way, where you don't have to really think, and then the harder way where if our instructions were a little more specific, we'd have to do it this other way. So we're going to go over both because I could be more specific on the test. So right here it says, find a quartic. Now remember, quartic means degree 4. Find a quartic polynomial with these as the only 2 real roots. So quartic is degree 4, and these can be the only 2 real roots. So it's only going to cross the x-axis at 2 and 8. So then there has to be 4 solutions. So what do we know about the other 2 solutions? They're imaginary. So there was not a lot of requirements there. We got to create our own. So let's say x equals I and x equals negative I. They have to be conjugates, don't they? So we've now met all the criteria. We have 2 imaginary, 2 real, and we're going to create our own quartic. So I could have used 2i and negative 2i. I'm just using the easiest one possible. So now work backwards. So we would have an x minus 2. We're going to have an x minus 8. We're going to have an x minus I. And we're going to have an x plus I. So now we're going to multiply these 2 together, combine like terms, which would be x squared minus 10x plus 16. Then we're going to multiply these together, so we would get x squared. We're going to have plus ix minus ix, and then minus I squared, which would be plus 1. And now we would distribute this through, so we'll have x to the 4th plus x squared minus 10x cubed minus 10x plus 16x squared plus 16. So now in standard form, we have met the criteria. We have a polynomial that has these as the only 2 real roots. And so yeah, we've done it. So yeah, we better finish up and write it in standard form. You're right. And we have met the criteria. Now that was easy because we got to come up with our own. Now over here it says find a quartic. It's saying the same thing, but I'm going to be more specific. It says find a quartic polynomial that is a transformation from the parent function. We have written one that is not, right? Multiple x's here. So if we have to do a transformation from the parent function, then we would say, what is the parent function for a quartic? So that would be y is equal to x to the 4th. True? Now a transformation on a quartic would have this form. Y is equal to a times x minus h to the 4th plus k. So we need to figure out how to create this so that it only has 2 and 8 as the real roots only. So everybody look. Graphing it somewhat helps. Like starting with graphing the zeros. So if it's crossing at 2, it would cross right there. And if it's crossing at 8, it would cross right there. Correct? So we're going to have some quartic. We do get to create it still somewhat. Now think about it. Just like a quadratic, halfway between the zeros would be, it's going to be evenly split. Would be like our quote-unquote vertex. So what's the halfway mark? 5. So this is our vertex technically. So we do know the shift left and right, don't we? It used to be at 0, didn't it? The middle, everyone? A quartic was split in the middle like this at 0, so didn't it shift right 5 units? So let's write that down. It shifted right 5 units. That had to happen to give me those zeros. Now here's the next question though. We need to know how far down we went. We could have gone down that far. We could have gone down that far. We could have gone. Do you guys see how we don't know how far down we're at? So we got to figure that out. Isn't that the plus k part? Okay, so let's plug in what we do know. So we do know this so far. We have a y, we have an a, we don't know our a. Our x minus 5, we do know because that's our shift of right 5, so x minus 5 to the 4th plus k. Now we get to create our own. So I would rather create so that a is 1. Do you agree?
Yeah.
So I'm just going to say a is 1. Now we can't say k is anything because it's very specific. K is specific to create it to land in these exact spots. So now what we can do, guys, is we can take a different, some xy point on the graph, some xy point on this quartic, and plug it in for x and y, and then solve for k. So what's a point on the graph? Over 2 up 0, or over 8 up 0. So let's just use the smaller one. 2, 0 is a point on the graph. True? So let's plug that in. X, y. So y is 0. So 0 is equal to, my x is 2 minus 5 to the 4th plus k. And look at that. I only have one unknown now. 0 is equal to negative 3 raised to the 4th power plus k. So we have 0 is equal to 81 plus k. Now solve for k. So we'd subtract 81, wouldn't we? So k is equal to negative 81. That would be true if that is a point on the graph, and it is. So we would go back to right here. We'd say we just found out what plus k is. It's actually minus 81. This is a quartic polynomial that would give me this and this as the only two real roots. Now let's say you're like, did I do this right? Set it equal to 0, add 81, 4th root it. You need a plus or minus and then add 5, and you would end up at 2 and 8. So you could check your answer by solving. Does that make sense? Okay, awesome. So this is what's considered technically the harder way, easier way, I guess. It depends on who you ask. Did it make sense to you? See where it shifted left and right. Plot the zeros. Then isn't the halfway between where you shift left and right, everyone? Think about it. If we have 0 over here and over here, isn't the halfway point the shift left and right? Because it used to be at 0, 0. Then once you know the shift left and right, put in what you know. So you know that the only thing you know is h. And then plug in a different x, y point, and that'll give you k. So what I want you to do is 11 through 19. On the odds, do it the parent function way, and on the evens, you can do it the other way. Okay. So if I said to you, here is a cubic parent function, determine the transformation that was used to this to get the following graph here. So first of all, I would start at 0, 0 and see where the new 0, 0 is. Isn't that the new 0, 0? Isn't that the shift of that point? So we would say, inwards we went left 1 and up 4 units. You guys see? Negative 1 up 4. Left 1 up 4. So now we'd say, okay, so we can put that in. So we know it's definitely this. Y is equal to, we don't know what A is. A times, and then it's, and this is a specific A. We're not creating our own. There is an A specific to this. So then we know it's x plus 1 cubed and then plus 4. Now let's figure out what A is. So we don't know what A is, but we do have an xy point. So plug in a different xy point. So look, xy, let's plug it in. So 5 is equal to A times my x is 0 plus 1 cubed plus 4. So then that's 5 is equal to A times 1 plus 4. So then we have 5 is equal to A times 1 is A plus 4. So A equals 1. So now we can go back here and say, so A was 1. Does that make sense, everyone? Okay, one more like that. Let's do, there's just one more like that right here. So you'd say, okay, my new 0, 0 became this point right there. So it was shifted right 3 down 2. So we'd say, okay, so y is equal to A times right 3 would be x minus 3 cubed, and then down 2 would be minus 2. Then you'd say, what's another xy point on the graph? Either 1, 6 or over 4 down 3. So that's an xy. So my y is negative 3. We don't know what A is. Our x is 4 minus 3 squared minus 2. So then we have negative 3 is equal to A times 1. That's not a square, that's a cube. Cubed minus 2. So then we have negative 3 is equal to A times 1 minus 2. Negative 3 is equal to a minus 2. So add 2, we get negative 1 equals a. So we go back to a and say it wasn't just 1, but it happens to be negative 1. Do you guys see what I'm saying? Okay, awesome. So make sure you could do one like that for the test. There's not any on your homework, but high chance on the test. So here are a few more. If you want to practice before you go, I highly recommend at least doing 1 or 2 of these somewhere in your notes.